Okay, so for this first one, I got really close. The big mistake I made was I wasn't able to calculate the density. Um, and the key thing here was the ideal gas law. You can rearrange that to solve for the density, then use the molecular weight to convert that to the proper units. Then with the area and the velocity, you plug that all in, and to get to the mass flow rate. And I got really close. I didn't get the density, and I also didn't list my assumptions, which were here listed here. And then for the conceptual, I got that one wrong. The momentum balance kind of explains it well. As the relative velocity increases, the mass flow rate decreases. Or I'm sorry, it increases, but it's negative. So that was kind of my rationale with that. But that decreases the thrust, so the thrust would decrease. Next, I almost got this one right. I just didn't multiply by some sort of, I must have plugged in my calculator wrong. So I was off just by a factor of 10. So I got really close there, so I just made sure I noted that right there. 3 part A I got right. But the key mistake I made on part B was for the isothermal, you can calculate the work per cycle for the overall, and that works because the temperature isn't changing between cycles because it's isothermal. So I was able to do that for the overall, which got the correct answer. But when I tried that for the adiabatic, that doesn't hold up because the temperature, um, it's not isothermal. So I just did it for one stage and then multiplied it by 4. So I just did the last stage from here to there, and then multiplied by 4, which got this. And then, yeah, because it's isothermal, the temperature doesn't change, making it easier and need less work to compress again. I got this one right. And then 4B, I got really close. I got the conceptual part right. I think my big mistake here was the fact that it is 1.29 meters below the water level of the other tank. So I subtracted that off, which got me that. Then for C, I didn't attempt this one on the exam. Here, the fluid is flowing through the porous bed at this length, at this speed. This is the pressure drop. The viscosity is given in the problem statement from right over here. And we just rearranged this equation to calculate the permeability. And this will get us in meters squared. And we have to use a Darcy conversion factor to convert from 1 Darcy, or to convert from meter squared to Darcy. And I got 54.6 Darcys. And that was the whole exam. I ended up getting this one right too. Thank you.